Okay, this graph tells us that the resultant electric field anywhere between the two spheres is never zero. There is no neutral point. This tells us that the two spheres cannot be carrying the same polarity of charges. For example, they cannot be both positively charged, because if they are, then you notice that in the region between the two spheres, the fields of these two spheres are in opposite directions. So there ought to be a point where the two magnitudes are the same, and therefore the two fields cancel each other out and creates a neutral point. But there isn't any neutral point, so this cannot be the situation here. Likewise, if you have the spheres both negatively charged, then we have the same conclusion, because in the region between the two spheres, the two fields are in opposite directions. So there ought to be a point where these two fields cancel each other out and giving us a field strength of 0. So this field can only be produced if the two spheres carry different charges. For example, this one is positively charged, whereas this one is negatively charged. So you notice now that in the region between the two spheres, both the electric fields are towards the right. That's why they'll never cancel out. Of course, the individual field strengths still follow the inverse square law. That's why the field strength is very strong near this sphere, a strong rightward field. The electric field strength is also strong when it's near this guy, a very strong rightward field. In the middle, we have a field that is weaker, but it's not 0 because it's also in the rightward direction. Alright? Strong rightward field, not so strong rightward field, strong rightward field. Of course, it's also possible for this one to be negatively charged and this one positively charged. The key is if they carry opposite charges, the electric fields will be in the same direction, and that will tally with what is shown in the graph here, that there's no neutral point. Okay, I hope I have made it clear. Basically, if they carry the same charges, then we expect a neutral point at the middle. If there's no neutral point, then we know that the two spheres must be carrying opposite charges. Okay, ta-ta!